Yashoda. I am working as an assistant professor in SNS College of Engineering. Today we'll discuss about complex integration. So what is complex integration? So complex integration it is a integrating functions of complex variable along a path in a complex plane. It's called complex integration. In this complex integration, we are going to explain about Cauchy's integral theorem. So what is Cauchy's integral theorem? It states that f of z be any analytic function and its derivative f dash of z, it is continuous at all points inside and on a closed curve C. Then integral over C, f of z dz value will be equal to 0. For example, let f of z be any function, right? So let f of z be any function and this function is analytic at all points inside and on a closed curve C. Then we can say that by Cauchy's integral theorem, integral over C, f of z dz value will be equal to 0. Clear? So Cauchy's integral theorem is nothing but f of z is analytic at all points inside and on a closed curve C. Then directly we can say that the integral of f of z value will be equal to 0. So next, Cauchy's integral formula. So what is Cauchy's integral formula? If f of z be analytic at all points inside and on a closed curve C. Right? Clear? F of z be analytic at all points inside and on a closed curve. Then there exists a point A. There exists a point A within C. Within C. Then by Cauchy's integral formula, and which theorem, this theorem states that integral over C, f of z divided by z minus a into dz value will be equal to 2 pi I into f of a. This is called Cauchy's integral formula. So what is Cauchy's integral formula? F of z is analytic at all points inside and on a closed curve C. Then there exists a point A. In that point, the function which is not analytic, that point exists within C, right? The point exists within C. Then the value of integral over C, f of z divided by z minus dz equal to 2 pi I into f of a. Next we will see the problems. First problem, evaluate integral over C z divided by z minus 2 into dz is equal to, where mod z is equal to 1. So now we are going to evaluate the function integral over C z divided by z minus 2 into dz, and the region is given mod z is equal to 1. Our closed curve is nothing but mod z is equal to 1. So for evaluating this function, we are going to solve. We are going to do the fourth step. So first step, identify the closed curve, right? So here our curve is mod z is equal to 1, right? So what is mod z? So we know that z is a complex number x plus iy, and the modulus of z will be calculated by root of real part square, that is x square, plus imaginary part square, that is y square, right? So now taking squaring on both sides, we will get mod z square is equal to x square plus y square, and we know that mod z is equal to 1 and this equation will be equal to x square plus y square is equal to 1. So clearly there is a circle equation with center 0, 0 and the radius 1. So now draw the region. So take radius 1 distance from x-axis and y-axis is 1, 2, 1, 2, 1, 2. So join these points. So we will get a circle. These are closed region. Mod z is equal to 1. So first step, identify the closed curve. So we have identified the closed curve as circle with center 0, 0 and the radius is 1. Next, the second step is to find singular points. To find singular points. So to find singular points, just equating the denominator is equal to 0. So the denominator value will be z minus 2. This is equal to 0. Just denominator equal to 0 to find the singular points. So from this equation z equal to 2. Therefore z equal to 2 is a singular point of given function. Right. So next step, our third step is to find the singular points whether it is lying inside or outside the circle C. Pause.